Hello, ladies and gentlemen. This is approximation and estimation part 11. And the subtopic here is significant figures. This is straightforward, and most of the question we solve in mathematics, they can ask us to approximate to 2 decimal place, 1 decimal place, 4 decimal place, or one significant figure, 2 significant figure, 3 significant figure. Okay, so that is why this is very important, so that you can get your full mark. Okay, so but we just need to know one or two things. We also have this applicable in decimal place, but it's quite different. But decimal, I've explained that. But for significant figure, um, the first thing you need to note, there's a short form. The short form of significant figure is S dot F. Okay, S dot F. In case you see S dot F, okay, that is what we mean by significant figure. Most of the time, you might not see it written in full, but you will see it written in short form, S dot F. Okay, so please, you need to note one or two things on that significant figure so that we won't mix it up with decimal numbers. Okay, and the first significant figure must be a non-zero. Okay, in decimal we can count 0, but in significant figure you cannot count 0. Okay, so the first one you need to count must be a non-zero, must be a figure. What do I mean by non-zero? It must be 1. Okay, like non-zero means it can be just from 1 greater than equals to 1. Okay, so that is the meaning of non-zero, greater than equals to 1. That is 1, 2, 3, 4, 5, and and so on. Then the next one you need to know is applicable to both decimal and whole number. Sometimes you will solve questions, maybe let's assume the answer is 0.00457. So the first, from what I just mentioned, 0.0045. So the first non-zero that is greater than equals to 1, the first non-zero in 0.0045 is 4. Okay, so all the 00 you don't count it. Then you also apply to whole number. Let's assume you solve the question and you get maybe 734. Okay, so and they ask you from that 734, approximate it to one decimal number, one non-decimal rather, one significant figure. So the first figure is 7. Okay, there's no 0 in this part. So we'll solve example as we move on. Then we also have digits 5 and above, round up to the next digit. Of course, we do that in decimal. Okay, if you are asked to approximate to 5 decimal place, 2 decimal place, you look at the next digit. If the next digit is equal to or greater than 5, as mentioned, in my part here, so then you round it off to the next digit. So that the same thing applies here. Now, zeros between numbers counted, so you need to count zeros between numbers. Okay, so that is, if we'll have an example here so that we can understand it better. So zeros between numbers, that is, if I have 0 points, let me just give an example here. Let me just say if I have something like this, 0.003045. Okay, so if you look at this 0, from the law of significant figure, all these 0.00, you don't count it. Okay, because they are zeros. But the non-zero start from what? 3. Okay, now if you look at this very well, now this 0 is between numbers. That's the meaning. 0 between numbers. 3 is between 3 and 4, so you need to count it. Let's assume they said I should approximate this one to 2 significant figure. So it means the first one is 3. Okay, 0.003. I will count this 0 because it's between numbers. Okay, that will be 30. So that's 2 significant figure. So I just give an example so that you can see what I'm trying to say. So for the digit of 5 and above, round off, I can say, let me give you 0.705 5. Okay, and you are asked to approximate this to 3 significant figures. Look at it very well. The first known zero is what? 7. And this 0 is between number. I will count it. If it is 3 significant figure, that will be 0.705. Now look at the next digit. The next digit here is what? Is 5. So don't forget, it states that digit 5 and above round up to the next digit. Now the next digit that follows after that 3 significant figure is 5. So I will approximate 1 to this. So it means the answer will now be what? 0.706. Okay, so that is the meaning of that. This is also applicable to decimal too, and we've done an example on that and you've seen it, so we don't want to dwell too much on it. Okay, so we all know the meaning of decimal and whole number. Now we want to go to Fox first example here. So the first example that we'll touch base with is we have example 1. So this example 1 is also express 0.000, that's 3074682, 0.000744682 to 1 significant figure, 2 significant figure, 3 significant figures. Look at the short form. You see, I've told you the short form of significant figure is S dot F dot, something like that. So now we are asked to approximate this to what? To different significant figure. Now, if you look at the question very well, if you look at it very well, it starts with what? 0.00. So the ones that it starts with, we don't need it. Okay, we don't need 0.00 in the answer. So let me just quickly write the solution here. Solution. So 0.000744682. So the first one say to 1 significant figure. Now to 1 significant figure, I've told you that you don't count 0.00. This one is different from decimal place. As simple as this thing is, it comes out in all solutions that you solve in mathematics. At the end of the day, when you solve your question, you might not be able to get your full mark, and most of these exams, they attach mark to this, maybe like 2, 3, 4 marks. Okay, because most people, when they solve, they forget to approximate based on the question. That is why this approximation and estimation is very important. Okay, so now here we are asked to approximate to 1 significant figure. So if you look at this very well, 1, you don't count 0. What do? The first non-zero here is 7. You understand? So it means that to 1 significant figure, I will have 0.0007. That is the answer. So now the next digit after 7 is 4. It means that it's not greater than or equals to what? 5. So here it's not greater than, see that this 4 here, this 4 that you have here is not greater than or equals to 5. Not. It's not. Okay? Because it's not greater than or equals to 5, then there's no need to approximate 1 to this. So you leave it. So that is the meaning. So it means that the answer here is what? 0.0007. So for the second one, which is what? 2 significant figure. Number 2. Number 2 says 2 significant figure. So you have number 2 here, 2 significant figure, 2SF. Okay, so now if you look at it very well, for 2 significant figure, it will be what? 0.00075. Very simple. If you look at the 6 you have here, the 6 you have here is what? Is greater than or equals to what? 5. This 6 here, okay, is greater than or equals to what? Equals to 5. Then it means that you approximate 1 to 4. Okay, that is why we are having 0.00075. Instead of writing 4, you will write what? 5. Okay, so and then you can also try the one for what, three significant figure. That one is also very simple. Okay, so for three significant figure, number three, you have 3s dot f. That will be what, 0.000747. Okay, so and you know why that one is 7. The next digit there is what, 8, and 8 is greater than equals to what, 5. Please, you are benefiting from this, from this knowledge. Okay, continue to share. You need to share so that we can reach a lot of young minds. Okay, continue to like, continue to comment. Okay, it won't be okay if you're benefiting and you're not sharing for other people to also learn. Okay, follow us on our Facebook, on TikTok, on Instagram, and also subscribe to our YouTube channel. Thank you very much. Cheers.